Alright, in section 8.5, we're going to be looking at adding and subtracting, and also looking at more complex fractions. Starting off with the basics, I've got example 1 here, kind of leading into what we're going to be getting into. Example 1 is, I got 3 parts. The first one is 8/3 plus 2/3. This is something you would have seen back in your basic math days. Anytime that you add and subtract, they have to have what are called common denominators, where both of the fractions have the same thing on the bottom. You notice in both these cases you got 8/3 plus 2/3. All you do is you add the numerators together. 8 plus 2 is 10, and you put it over the common denominator, which is 10/3. So you have 8/3 plus another 2/3, you now have 10/3. And the same thing goes if you have other things on the bottom as well. If you notice, these have variables, but they do have the same thing in common. 4x and 4x are the same, so you simply add the numerators together. 7 plus 3 is 10 over the common denominator. And then in this case, you always do want to look to see if you can simplify further. In this case, if you notice, 10 divided by 4 can be reduced. 2 goes into 10 5 times. 2 goes into 4 twice, so that reduces to 5 over 2x. And then the last one, for example 1, is part C. This one has a binomial on the bottom that's got a 2-term statement, but the x plus 6 and the x plus 6 are both the same. So just like the previous two, you can subtract those. And on top, in this case, you don't have common like terms. Okay, they are not the same. 2x minus 5 cannot be put together as one term, so you leave them as 2x minus 5 over the common denominator. And that is your answer. Okay, so looking at some review problems before we get into the actual difficult part to this section, because in my opinion this is one of the hardest sections we'll do all year. Let's look at a couple review questions. We're going to do this without a calculator. So review question A says add 4/3 plus 3/2. Now this is a little bit different than the one we had up here. 8/3 plus 2/3, they had the same denominator, so this one wasn't too hard. This one though is a little bit more difficult because we don't have those common denominators. So what we're going to look to do is to make them the same. So if you think about it, between 3 and 2, a common multiple, not a factor, but a common multiple, is 6. Okay, so I want to figure out, what do I need to multiply this 2 by to get a 6? Well, I can multiply it by a 3, and I want to multiply the top by the same thing. That way I'm multiplying by the equivalence of a 1. Same thing over here. I can multiply this 3 by a 2. Again, all I'm doing is multiplying by 1. 2 divided by 2 is 1. And now when I multiply these, 2 times 4 is 8. 2 times 3 is 6. Over here, 3 times 3 is 9. 2 times 3 is 6. And if you think about it, these reduce down to what we originally started with. 8/6 is the same thing as 4/3. 3/2 and 9/6 are also the same thing. So you haven't changed what these are equal to. So now that they have common denominators, we can simply add the tops. 8 plus 9 is 17, all divided by the common denominator of 6. And that will be our answer. And then just another one for practice. This one's a subtraction, but the same thing. They do not have the same denominators, so a common multiple in this case between 4 and 5 is 20. So I'm going to multiply the right fraction by 4 over 4, because 4 times 5 gets me 20. I'm going to multiply the left fraction by 5 over 5, because, again, 5 times 4 gets you 20. So on top, 5 times 1 is 5. 5 times 4 is 20. And if you think about it, 5 over 20 and 1/4 are the same. 2 times 4 is 8. 5 times 4 is 20. Now that we have common denominators, we can subtract the numerators. So 5 minus 8 is -3 over 20, and that does not reduce, so that is our answer. And the reason why we did this entire page is to lead into the difficult stuff we're about to get into. These are all very basic examples of adding and subtracting fractions. So we're going to look at one that's a little bit tougher. This is example 2 in your textbook, and I'll do one that's not in your book. But here's the first one. So if you notice, these two are clearly different. Okay, they have 9x squared over here, 3x squared plus 3x over here. But this one's not as simple as the ones where you just have to multiply by a number. This one's a single term, that one's got 2 terms. What we're going to do for every single adding and subtracting is we're going to look to factor all of the denominators. So I'm going to leave this first one alone because I can't factor 9x squared. I'm going to leave it alone. But I can factor the bottom of the right fraction. Between 3x squared and 3x, I can remove a common factor of 3x. And if I do that, I'm left with x plus 1. So that's your first step. Every adding and subtracting question, factor the denominators. So now what I'm going to do is I'm going to do the same thing I did in the last question. I'm going to try to get them to have common denominators. So I'm going to start off with the numbers first, 9 and 3. Between 9 and 3, a common multiple is 9. I can multiply this 3 right here by another 3. So I have a 9 over here, then I have a 3 times 3, which is also a 9. Then we'll move on to the next thing, which is this x squared. This side has an x squared, this side has an x. They're not the same, but I can multiply this x by another x. X times x is x squared. This side is already an x squared, so I've already got a good portion of my problem done. 9x squared, and then 3x times 3x is also 9x squared. The only difference is now is that this right fraction has an x plus 1 that this left side does not have. So I'm going to multiply the left side by x plus 1 over x plus 1. Okay, so when I do that, if you notice, I've got x plus 1s on both denominators. I've got 9x squared when you multiply the 3x and 3x on both sides. So they now have common denominators. So what I can do now is simplify the tops. So I'm going to distribute the 7 to the x to get 7x. 7 times 1 is 7. And I'm going to leave my denominator in factored form. You do not want to simplify that. 9x squared will come out front. And then the x plus 1 that we're multiplying to it is going to stay as it is. Now I'm going to do the same thing to the right fraction. Plus x times 3x is 3x squared. And I am going to simplify this just a tad. 3x times 3x is 9x squared. And then the x plus 1 drops. So if you notice, they are the same. So what I can do now is simply add the tops, and you put your final answer over that common denominator. That common denominator is this. That's not going to change. But when I add the tops, I'm going to put this in standard form. I'm going to put my x squared term first, because if you notice, 3x squared, 7x, and 7, none of those are like terms. So I'm just going to put those in the order they're supposed to be in. 3x squared plus 7x plus 7. And then from here, you will look to see if you can factor and cancel further. In this case, if you look at it, if I try to factor the top, 3 times 7 is 21. There are no factors of 21 that when you add them will get you a 7. So since the top is not factorable, this will be your final answer. Okay, I'm going to do another one just like example 3 on the next video. So if you want to watch that one, click on the next video.